Oh, hello, people. Hello, Debianites. We are going for the next session. Today with me, we have Mark Asselstine. He's from Wind River, and he's going to present a unified approach for intelligent deployments at the edge. Let's welcome him.
Hi, everyone. My name is Mark Asselstine. This is my first DebConf. Exciting to be here. As was mentioned, I work at Wind River. I have the title of Principal Technologist in the open source software group. So pretty much anything in Wind River which has an open source component to it, I'm involved with. So seeing as this is not only my first appearance at DebConf, but it's actually the first official time that Wind River is represented here at DebConf, I thought I'd take a minute just to explain who Wind River is, or what Wind River is, and what we do, because it's going to make some sense as we get through this presentation. So Wind River actually has a fairly long legacy in open source. About 20 years ago, Wind River started making what's known as Wind River Linux, which is an embedded distribution for Linux. It's used all over the place. Most commonly, though, is found in telco equipment, but we're also in medical devices and all sorts of other interesting things that you find out there that are deemed embedded. So during this work, over these 19 years, we partnered with Intel to be the founding members of the Yocto Project. I'm going to go into detail exactly what the Yocto Project is in a minute, but essentially it is a distribution builder. So it gives you tools to make a Linux distribution, and it's designed for embedded systems. We're also founding members and the main drivers behind the StarlingX project. StarlingX is a cloud stack for infrastructure, again, mostly used in telco environments. If you're using 5G cell phone technology, a lot of that is being run on StarlingX. Lastly, Wind River donated the source code for the Zephyr project. Zephyr is a small real-time operating system. I was actually just in the news the other day that Arduino is going to adopt Zephyr for their main IDE and as their underpinning OS. So again, we donated the source code for that, and also are a member of the Zephyr project. Not as involved as I would probably like, but yeah, we're still members and participate in that project. Now, the one thing you might notice on here is Debian is a bit absent. You know, the question is, what's this guy doing in front of everybody here that worked on Debian, when it doesn't appear that he actually gets involved with Debian? But that's changed recently, so I'm going to explain how that is. So as I mentioned, Debian, or Wind River, participates in the StarlingX project. And at the time, StarlingX was open source. It actually made use of CentOS as the base operating system. However, late in 2020, Wind River, or Red Hat, announced that CentOS was going to go to CentOS Stream, essentially taking a stable release process and turning it into a non-stop feed of updates. And unfortunately for the StarlingX project, this wasn't a suitable solution. And so quickly, the StarlingX project had to adapt their plans. It had some immediate effects. So work that was underway to move StarlingX to CentOS 8 immediately came to a halt. And it also brought up concerns about building a product or even building a project on proprietary operator, an operating system which was under control of a corporate entity. As Hector mentioned in his presentation, freedom means different things, and having that control from Red Hat was removing some freedoms that were needed. So what happened when this announcement came out was that the StarlingX project quickly had to do some analysis as to where they should go. and they looked at alternatives, and Debian was on that list. A group from the StarlingX project, including myself, reviewed what was available, and we loved the Debian community. To be honest, it was fabulous to actually have a community involved in something I was working on. I've used Debian since the late 90s, so to actually have an opportunity to bring that into something that Wind River is interested in was very exciting to me. We did a few things in order to come up with a solution that included Debian. So we did have to port a whole bunch of packages for StarlingX. So again, StarlingX being a set of cloud infrastructure, there were certain packages that were missing in Debian that we had to create. We're looking to contribute those to Debian and become maintainers of those packages. It just hasn't happened yet. The timing hasn't allowed for it. We also did a few things around OS tree. So StarlingX required updates to be done in an atomic fashion, and OS tree was a technology that we've been using before, and it was partially available and workable with Debian. So we brought OS tree into the image. And the other thing we did was to integrate and validate the solution. So Debian started becoming part of StarlingX after this announcement in 2020, and we've started down this journey to use Debian in the StarlingX project. Now we're using the kernel from the Yocto project. Just to be clear, it's mostly user space that we're bringing in from Debian. So at this point, Debian is part of what? So yeah, in the end, the journey to Debian with StarlingX was challenging, but very rewarding. And at this point, StarlingX is actually in deployment, as I said, on thousands of nodes for 5G RAN applications. Now, one of the other things that we learned while doing this work on StarlingX was that Debian is very suitable for running on edge devices. So just let me go quickly into what edge devices are, because I'm not sure if everybody here has worked with edge devices and embedded. But if you quickly Google for edge devices, you'll typically wind up finding results related to networking equipment. So in networking, routers, switches, multiplexers are often seen as edge devices. But if you go a little bit further, you'll find that there's other classes of edge devices that exist. So these will include things like automotive, medical devices, devices that are used for artificial intelligence, doing inferencing without having cloud connectivity or limited cloud connectivity. Just to be sure, though, I want to keep our definition of an edge device to devices that actually run Linux. So things like PLCs and microcontrollers, we're not going to cover here today. And also edge devices that run other operating systems such as Android. We'll leave those out of the definition for today's purposes. So one of the things that you quickly find when you start working with edge devices is it brings in quite a few challenges when you're actually trying to use and deploy Linux on edge devices. So I'm just going to go through a few of those now. The first challenge is around the diversity of CPUs, so CPU architectures. So the main architectures that you'll find on edge devices are Intel, ARM, MIPS, and PowerPC. And then to make things even more complicated in this space, you end up with dealing with multiple variants, especially on the ARM side. You might have soft float versus hard float. And then, of course, the big set of variants being 32-bit versus 64-bit. And what you end up, when you actually bring all these into the picture, is you end up with a fairly large matrix of we often call it matrix of pain, because each one of these means that you have images that must be tailored for a different environment, and it makes it difficult to create one solution for Linux that's going to work across all devices. And not only that, but you'll even find edge devices that will have different variants that will, they'll be the exact same device that serve the exact same purpose, but one might be MIPS and one might be ARM. Challenge number 2 is around resource limitations. So unlike desktops and servers, usually edge devices have limited resources. So the big ones when it comes to that is storage. So how much space is available to host your operating system and user space. RAM is another one, what you can actually run at the same time on your device. Power consumption is one that you don't normally find again in servers, maybe in laptops, but in edge devices can be a fairly important piece to the puzzle. So this might affect how often you can run a job, for instance. And then the last one being compute. So similar to power, compute will restrict what you can actually run at any particular point in time. Now, the other thing to keep in mind when you're thinking about resource allocation is not only does your application need to use resources, but your operating system, and you have to have a balance there so your OS doesn't consume everything, preventing you from running your application software. Now, on edge devices, you usually have choices here as a system designer. You might swap out your init system. So you might take system V out of the picture and use sysv init, or you might even do something drastic, like using a different supplier for libc. So you might use muscle instead of glibc. So there's a need to customize in order to make use of the resources that are available. The third challenge is around cross-development environments. So edge devices themselves typically aren't useful for developing your operating system on or your applications. They're, because of the resource constraints and also because of lack of I/O, you're typically going to use a laptop or a desktop in order to actually do your development on. And then you're going to take your images and deploy them to your target. If you bring into the mix the fact that you have different CPU architectures, you basically need a cross-development environment. Most of your desktops and servers that you have nowadays are going to be Intel, possibly ARM. And again, your target device might be MIPS or PowerPC. So you need a cross-development environment to support them. The fourth challenge is around updates. In today's connected world, pretty much every device is connected to something. Because of the fact that CVEs are constantly coming out, and remember, when CVEs are announced isn't exactly when the CVE was actually injected into your equipment. So pretty much whatever you ship today is going to have bugs in it, and some of those bugs will be CVEs. So you basically need to perform updates. Edge devices can be deployed anywhere. Sometimes it's expensive or impossible to get access to them. For those of you that were here during Hector's talk, he had pictures of moon rovers. It costs a lot of money to send someone to the moon. So if you have an OTA update fail on you, you may not be able to recover, or again, it's very expensive. So basically, updates can't fail. The other thing around updates too with edge devices is they typically have AD schemes, so they'll have a safe fallback that you can go to. So again, in the end, the key takeaway being that if you do fail, you have to be able to fail gracefully. And the last challenge I'm going to cover is around bootloaders, kernels, and board support. I've already spoken with one gentleman here earlier talking about the variation in bootloaders on his devices. Actually, I've spoken with two people already on this. We were talking about the ability to use Chromebooks and the fact that the bootloaders are very custom on those devices. And so yeah, this is a challenge. As well, when you're looking at most edge devices, they're coming from multiple suppliers. So TI, NXP, for instance, each of them produce SDKs, which include the bootloaders, will include kernels that have sometimes hundreds, sometimes even thousands of patches against them. So these are challenging environment for a binary distribution such as Debian or Red Hat or any of them. So in summary, again, we have all these challenges that we face when we're developing for edge devices. Now, I know some of these are definitely common with servers. OTA, for instance, when you update your server, you also don't want it to fail, or you want it to fail gracefully. But when you actually put the requirements for solutions for these challenges, the ones for edge devices, they're going to be different solutions that you're going to be coming up with for edge devices than if you're talking about servers or environments where you would typically find Debian. So again, here, most binary Linux distributions aren't necessarily solving for the problems of edge devices. They're solving for a different set of problems. And again, as I mentioned, these challenges aren't unique to the edge, but the solutions often are. So I'm just going to go quickly through an example. All of us have Wi-Fi routers at home, or I guess most of us will have Wi-Fi routers at home. And even though you can put Debian on Wi-Fi routers, or you can even make a router using a PC and other equipment, and maintain that using a package manager and going through the motions that you would using Debian for that. Typically, this isn't the case. So when you buy a router from your local computer shop, it's going to come with a piece of firmware on it, and you're going to use your Android phone or Apple phone in order to hit a button to perform updates. And those updates are typically what I call a firmware update. So it's one complete piece of software that's going to be sent to the device, and again, it's going to do usually an AD system update in order to make sure that the device can fail gracefully. Recognizing this type of challenge and scenario, Wind River in 2011 partnered with Intel, and as I mentioned at the start, we founded a project called the Yocto Project. I'm not going to go into too much detail of what the Yocto Project is, and I think there's actually a talk tomorrow which is going to also cover Yocto and Debian. But the Yocto Project is what we call a source-based Linux OS solution. On their page, as you'll see, it's actually what's called a distribution builder. So the nice thing with Yocto is it offers several benefits. Because it's source-based, you can change pretty much everything. How a package is configured, which patches are applied to that package, which packages are in an image, how the image gets written to your media, all of that is customizable. By adding that or having that customization, you can essentially have a solution that meets your use case. It offers a cross-development environment that you can run on your laptop. Not only that, but when you actually build an image, it will build an application SDK for you, so you can do your application development using a nice cross-development environment. And it is well suited for a firmware model. So basically, again, because Yocto can produce any type of image, you can produce firmware, which you can then deploy to your edge devices. So when we look at our challenges again, and we compare that with the Yocto project, you can see that for every challenge that the edge has, the Yocto project seems to have a solution. Now, I've spent the last 17 years at Wind River essentially working with the solution with many of our customers, and I can tell you that it's a very well suited for this type of use case. But there is a very large caveat in that it has a huge learning curve, and it also, the customization and the extensibility comes at two costs essentially, which is time and complexity. The other thing that it ends up happening when you work with the Yocto project is that you're distracted, I guess is the best way to put it. You're too focused on the platform and not focused enough on your application. So when you're making an edge device, you really want to focus on the functionality of that device, and you don't want to be worried about the operating system. Unfortunately, the Yocto project does have that high upfront cost. The other challenge with the Yocto project is if you don't modify anything, you're just rebuilding what other people have rebuilt, and you're not benefiting from them having those packages already built. So you end up throwing a lot of compute at the problem. And again, with compute, you do need to have fairly large build systems and laptops and other things in order to support your ability to build and deploy with the Yocto project. So even though it solves our main challenges, it brings with it some of its own problems. Now, we have noticed in the last few years, though, that there is a changing landscape when it comes to the edge device. First and foremost is that the CPU architectures that I mentioned at the beginning, PowerPC and MIPS, have pretty much disappeared. They no longer, I don't believe either of them have a corporate sponsor anymore. For example, the MIPS architecture, we actually employed at one time the maintainer for MIPS, and he no longer works on MIPS. So it's pretty much those two architectures have gone away. Now I know some of you might wonder why RISC-V isn't up here. So far, we haven't had much traction when it comes to RISC-V. We are ensuring that we're still prepared for RISC-V, but essentially at this point, we haven't seen enough momentum to worry about it too much. The other thing that's happened is all the new designs are using 64-bit, so you don't find 32-bit systems this new designs being built on 32-bit. So the number of variants are dropping. And again, ARM was probably the worst offender for variants, whereas with 64-bit and ARX64, ARM is now one of the better ones. For bootloaders, we're seeing a lot less variation in bootloaders. UEFI is now available on lots of ARM systems. And where UEFI isn't used on ARM, it's almost always U-boot now. And the last one, as I mentioned before, you need to have servers and laptops. If you don't want to do cross-development, your target as well as your build systems have to have the same architecture. And now there are lots of powerful ARM64 systems that you can use, so you don't have to have a cross-development environment. In addition to some of the technical challenges that we've seen cleaned up in the landscape around edge devices, there's also a push for some other more peripheral things around your operating system. So one of them is SBOMs. So I don't know if everyone's familiar here with SBOM, but it's a bill of materials. It's required to meet a lot of requirements, especially in the US, around cybersecurity. The EU also has requirements coming in for operating system for SBOM declarations. Again, if you have the Yocto project being source-based operating system that you're only deploying at the edge, but all the machines that you're connecting to are being supplied by another operating system vendor, you have to have multiple SBOMs. And that also brings in multiple CVE trackers, multiple SLAs that you're going to be having from each of your vendors. So basically, if you have a heterogeneous solution, which is what you'll get with a source-based solution for the edge, you're going to have to deal with these other problems as you move into the core. The last point being the important one here is that you end up having increased effort and training. So you're going to have to be training for a Yocto project as well as your other operating systems that you have coming into the core. So ideally, you want to move to a single supplier that can provide you the savings when it comes to time and effort. So this is the exciting part of the presentation. I do have more, but it's exciting because I get to stand in front of everybody here and announce that Wind River has created a new distribution. It's a Debian derivative, and we're calling it eLxr. Thank you. So yeah, so eLxr, as we can see here, we're basically taking the best of Debian. We debated many different ways to use Debian in this new solution, and in the end, we did settle on it being a derivative. This will give us enough flexibility to add in and modify the parts of Debian that we see are needed, especially for these edge-to-core solutions. We're using some of the more modern parts of Debian. So Hector talked about Salsa CI. We're heavily making use of GitLab and CI in order to maintain eLxr. Again, I've spent 17 years now working on Linux operating systems, and a lot of the manual work I'm not as excited to get up in the morning and do. So if we can bring automation to do some of that for us, that's great. On the core, we don't intend to modify Debian too much because it does what we need. So if you actually look at eLxr after this talk or after the conference, you'll find that on the core or the server side, it looks very much like Debian. We're not modifying many packages. And ideally, in my ideal world, the only packages that we're modifying and publishing are those related to branding, and that we work with the Debian community where we do see that changes might be useful to make. We'll be proposing those upstream. Again, with Wind River, we're used to working with a lot of upstream projects. So we also have no problem working with the components or the projects upstream from Debian to help affect changes. As we move out to the edge, eLxr does bring with it a set of tools that I'm going to speak about here in a moment. But yeah, it's exciting, and I'm hoping that the people here that saw the signs or have spoken to Wind River folks at the table, that you're going to check it out. So when we're talking about edge capabilities, again, eLxr does bring a set of edge capabilities. So if we sort of put together what I've spoken about here, if you look at source-based OS solutions such as the Yocto project on the left, you can see that you have fully customizable solutions. So as I mentioned, you'll be able to modify how packages are built, how they're patched. You'll be able to modify the images, what's included in them, all the way through. So everything is customizable with Yocto, but as I mentioned, it comes with a lot of time and complexity. On the right, you have something like Debian. So you have a binary solution. And here you can see that customization is really at runtime. So Debian produces and publishes ISOs. There are some solutions that you can use. I did put an asterisk down the bottom here, but generally binary distributions are only customizable after first boot. Now, the benefit of a binary solution and that after first boot customization is that there is a very large ecosystem to support that. So things like Ansible and Puppet, there are ways to affect customization, but it's rather late in the game, and especially when you're talking about embedded devices. So along with eLxr, we've included a set of tools. As I mentioned, we call them distro to order. And I'm going to demonstrate one of them in a minute here. But what we do is make use of the rich Debian package ecosystem. Again, I think Hector, when he was up here just half an hour ago, was saying around 48,000 source packages. I think it amounts to about 120 binary packages. So if we actually make use of the Debian package ecosystem, along with our distro to order tools, what you get is a way to build images for specific purposes. And so you add in a level of customization that doesn't exist with the normal set of Debian tools that Hector had spoken about during his presentation. So as you can see here, you can introduce a new package repository. So if you wanted to build the kernel and your own kernel modules, host them in a package repository, then that could be picked up by your tools that create your image. So if you wanted to get a custom kernel onto your device before first boot, this allows you to do that. So I'll just jump into a demo here. Sorry, the glasses is a new thing for me. All right. So what we have here is a manifest. So the distro-to-order tools that we've created, the primary input to them is a manifest file. So I'm not going to go into all the details here. If you know, I'm here all week, so not in the comedic sense, but I'm here all week to answer questions, and I can show you in more detail what's in the manifest file. But you can see it's fairly self-explanatory. We describe where source is coming from, or sorry, where the source tarball is, image. We're using Debian tools like MMDebStrap, for instance, to actually assemble the root file system. Now we can define the architecture, set up hooks for during the processing after the rootfs is created. We can basically use some customization. Here we're actually defining the packages that are going to be included in the image. And I can actually show you what that looks like. All right. So as you can see here, this is it's just a set of package listing, and MMDebStrap will make sure that it brings in any dependencies as you're using that manifest. The other thing that we'll do is we'll set up the disk partitions. And lastly, you can see here that we're formatting the disks. And in this case, what we're going to do is we're actually going to install K3S. And so in this demo, in under 10 minutes, we're going to build from scratch an image using Debian packages, the K3S installer, and we're actually going to start up a single node K3S instance in a virtual machine in about 7 minutes. So yeah, so that's the manifest format. And then we'll jump to the demo. And again, sorry if the text is a little bit small. If again people want to see more detail, I can show you guys in a more intimate setting, I guess, if you come and visit with me. So basically what we're doing here is we're running the install for the tools. So this is, at this point, we're just ensuring that our tools are available. And then once the tools are available, we're going to go ahead and we're going to run a build on the K3S manifest. I'll skip through a few parts because it's not going to be too exciting here, but here you can see MMDebStrap is creating the root file system. And I'm going to just skip ahead here as that finishes. All right, so at this point, MMDebStrap has created the root file system, and now we're starting to run some of those hooks. So you're going to see that we're going to set up the partition. And then at this point, we're going to go ahead and run the installer. So this is actually installing K3S. And then I can jump ahead a little bit further here. And this is all in real time. So you can see here, well, I went a little bit too far. Actually, here, I'll just go back a little bit to So this, sorry, I backed up a little bit to where, so the image is created, and then here we're going to launch it in a virtual machine. And then we're just going to jump onto that virtual machines console. All right, and then now I can jump back to basically at this point here, we're monitoring for K3S's nodes to be up and running. There's a little bit, because it's a virtual machine and we're on the console, you're going to get some interleaving with the console messages. So here you can see that the containers are creating, and then again, we don't need to watch all that. Eventually, they get to a point where they're all running. So again, that's where were we on the time scale there? It was 6:56. So in under 7 minutes, we went from having no image, creating an image, writing it to a disk, bringing that up in a virtual machine, and having a K3S instance. So we feel it's a fairly powerful tool. And in the manifest, you can include things like app.lstree. So app.lstree is another project that we've already written that we hope to contribute to Debian. Those of you that know OSTree, there's a package called RPM OSTree that Red Hat has. It basically gives you a hybrid, so you can either deal with image-based updates, or you can do package level manipulation of your image. So we've written app.lstree, which is an equivalent, not fully equivalent, but covers some of the main functionality of RPM OSTree. All right, we'll just get back to my presentation here. All right, so finally jump to conclusions. So again, Wind River is very proud to bring the eLxr project to life and announce it here at DebConf. We'll be having a bigger announcement at the Open Source Summit after we do our first GA in September. We welcome participation from anybody that wants to participate in the project. As I mentioned, source-based solutions such as the Yocto Project, they still fill an important need, but we feel that things are changing such that it's not always the best solution or the best option. But basically, due to the fact that CPU architectures have been reduced, the fact that you do have access to big build machines for ARM architecture, and along with our tools, such as the distro-to-order tools, we believe that building on a solution that builds on everything that the great Debian community has contributed to this space of binary Linux, that eLxr is going to be able to present and add interesting opportunities for us to work in that space from the edge to the core. That's it.
Okay, so now we have some time for questions. I guess the first one is from Andreas.
No pressure on that one.
Oh, no pressure. Thank you, Mark, for the presentation, and thanks for sponsoring the conference. It's also great. It's also great that we are the first one hearing about this announcement of eLxr. I like this a lot. One question, because you said you try to port something back, like OSB also. Do you see a chance that you have some members of your company who become Debian developers, work directly into the Debian distribution?
100%.
That's great.
Yeah, there's not even a question there. So, again, I didn't want to go into it too much with some of our history, but the Yocto project, since day one, we've been involved with that project. It's a Linux Foundation project that we provide. Not only does it it's involved in our day-to-day, and we contribute to it as much as we can. We always have debates whether we can actually do more. And with Debian, our plan is from the start to have people, some of which who will be exclusively working with the Debian community. We're still trying to hit that balance. As you know, with corporate interests, it's not always easy. But we will definitely, you will definitely see us in the Debian community. This is kind of our coming out party. We've been working hard, and obviously that meant putting as much focus as we could on eLxr, and also we did try to keep the announcement a bit under wraps. Now that we're public with the announcement, we hope that our involvement will also be more public.
Yep. Thank you very much.
Great. Welcome to the Debian family.
Thanks, Hector.
Yeah, and just a technical question on OS3. Did you consider also like CA sync or other solutions where other OSs tend to be like more AB and kind of remove partition?
Yeah, so the nice thing with the distro to order tools is the hook model that we have implemented will let you bring in other solutions. As I said, OS3 was one that we were familiar with. We actually used it with Wind River Linux on a blood monitor with Abbott Medical, and had very successful deployment. And that gave us a comfort level and with the tool, and we brought it in with StarlingX as well. StarlingX deploys tens of thousands of nodes within the Verizon network, as well as other networks around the world. And OS3 allowed us to be able to do those deployments not only quicker, but in a way where we could have better control over how the updates are done. But yeah, I always say it's software, right? You can change software anytime. If there's other solutions that are out there that are a better fit, we'll add in the hooks to make them available and explore them for different use cases and different solutions, or just different opportunities to do something different.
I probably missed an important concept. When building your image, how can you really run the bootstrap before creating the partitions?
So unfortunately, Chuck, who did the work, isn't here today. I've spoken with him on how it's done. I have not dug into how he's done that implementation. So what I'll do is I'll talk to you after, and I'll put you in contact with our developer that's worked on it, as well as the source code is available. So as I mentioned, eLxr is fully hosted on GitLab, and all the various projects are available now for you to see on GitLab. But yeah, I'll get your name, and I'll put you in contact with Chuck.
Thank you.
I know lots of the little details around the technical, but there's things that he did that are still a little bit of a mystery to me.
Oh, I also have a question to Chuck. Which partition type, which file system do you support in your partition tools? And do you support to partition multiple disks and using LVM?
So no LVM at this point. For most of the devices that we anticipate to use the distro to order tools, I don't anticipate that LVM would be used in those cases. We have talked about it, but at this point we've been more leaning towards keeping it out. Again, there are definitely challenges there with the order you do things, as you know from your work, I'm sure. So yeah, given the amount of time that we've been working on these tools, they still have room to grow.
Yeah. And what about these embedded devices? Do they usually have one disk or NVMe nowadays, or is having multiple NVMEs and making some software rate also interesting?
So most of the embedded devices do only have one storage device on them.
Okay.
Thanks for your presentation. I have a question about the SBOM. When we use the device.
Could you speak up a little bit? I'm only getting every second word.
Oh, sorry. Okay. I have a question about SBOM.
SBOM, okay.
Yeah. If we use Linux or software in embedded system, in CRA, they require us to give SBOM and give more supply chain information. So SBOM, anyone can generate SBOM after the binary generated, but I think ideally the best SBOM is should be generated when the binary generated. So in such point of view, if the getting help from Debian community to generate SBOM when the binary generated, and the eLxr can generate also the cross-border part, and finally the customer or end user can get more precise, correct supply chain information and getting the all information by first SBOM. So how do you think about the SBOM point of view?
Yeah, so your points are 100% valid. So with the Yocto project, again, being source-based, we do generate the SBOM as you build things. With SBOM with Debian, it's still on my reading list to see what has been discussed within Debian around SBOM. And it's probably one of the areas where we'll, back to the GPL question, we are going to probably work in that area first with the Debian community. There's work that could be done in Debian CD as well as I say, during package build to improve the SBOM tools in Debian.
I see. Okay. I also am interested in about the SBOM in Debian, so I want to join that thing.
That's awesome. Yeah. Thank you. That's it.
So let's thank Mark for being here. And if you guys still have questions, you can approach him afterwards. Okay. So thanks.